Very good evening and welcome back to the second session of chemical reactions and equations. Well, in the very first session that happened a day or 2 days ago, you have studied, or actually we have discussed the first part of chemical reactions and equations, in which we have started with how to balance a chemical equation. Right? So well, in this video we are going to continue the same balancing process. But then if in case there is somebody in this class, in right now's class, who have not attended my previous session and watching me for the first time, you're listening to Dr. Nasma Sheikh and I have been teaching chemistry from past 8 years. And I'm hereby going to help you out to understand the concepts of chemistry in an easy way so that you rock your class 10 CBSE board exams. So I hope everyone's ready with a pen and a book, because balancing is something which is acquired by practice, not by just listening or by reading. This is a recap of what we have done in the first session. We have learned step 1 in order to balance a chemical equation. In fact, let me quickly summarize whatever we have done in the last class, right? What is a chemical reaction is done. What is a chemical equation is done. And how to balance chemical equations is what is happening. In order to be able to balance any chemical equation, we have to learn 3 steps. But in NCERT, there are around 8 steps or so, 8 to 9 steps. But then you don't need to learn all of them. I have consolidated all 9 steps and brought them to 3 so that it gets easy for you to learn. You use these 3 steps even in your board exams, you're going to get full marks. And balancing is asked usually only for 1 mark. So it's no harm. The very first step is learned in the last class, and that is how to identify atomicity and how to identify number of moles. But then, as a quick recap, not a recap, but as a quick exercise, I am going to ask you 1 or 2 questions now. Get ready. Okay. So the very first one, tell me atomicity of maybe O3. Atomicity of O3. What is O3, by the way? O3 is ozone, isn't it? And the molecular formula of O3, ozone is O3. Okay. So now write down the molecular formula in the book and tell me the atomicity. Quickly. I already have so many answers in the chat. It's pretty good, and if you're not responding to me but just staring at my face, this is not going to help you out. You have to practice and you have to respond if you really want to learn balancing. So well, 3 is the atomicity. To identify atomicity, you have to just observe the subscript. And now, atomicity is nothing but what? Atomicity is nothing but the number of atoms. So O3 has 3 oxygen atoms. Now if I ask about 2O3, can you please tell me how many atoms of oxygen are there? This is what is the second step, right? Whenever you're dealing with this kind of questions, please ensure you observe the number of moles, that is prefix, and multiply the same with atomicity. So 2 into 3, I'm having totally 6. What? 6 atoms of oxygen. This is the first step in order to learn balancing. Hoping that you have watched my previous video and also have learned the same, I'm taking you today to the second step. Step 2. What is step 2 in learning balancing chemical equations? What is a unbalanced chemical equation? According to what we discussed before in the last class, unbalanced chemical equation is something which doesn't follow law of conservation of mass, right? But how do you know if an equation is following law of conservation of mass or not? I'll tell you now. Let's consider an equation. Which one equation? I'm considering a simple equation to begin with. S plus O2 gives SO2. This is the simple equation. Okay. What is this? This is burning of sulfur, right? Now, if you want to check this is balanced or not, what you have to do is apply step 1 that you have learned. What is that? Count the number of atoms. Okay, fine. How do I count the number of atoms? First, you identify the left-hand side and right-hand side of the reaction. Don't need to respond in the chat box. Write it down in the book and also try to sync up with my instructions. Okay? So whenever you are trying to identify an equation as balanced or not, the first thing that you have to do is write the equation and identify which is the left hand side of the equation and which is the right hand side of the equation. And how do you know which is the left hand and which is the right hand side of equation? Array before arrow mark and after arrow mark. That's it. Simple. Now, the later thing that you have to do is identify if you have any sulfur and oxygen atoms. You have, but then the thing is how many sulfurs and how many oxygens. As you have learned this step 1, identifying atomicity, now I'm expecting you to tell me how many atoms of sulfur do you have here on the left hand side here. I don't see a number, so should I take it as 0? No, you take it as 1. So you have 1 sulfur, right? The same way, how many oxygens? There are 2 oxygens, right? Now, do the same for the right hand side. Sulfur and oxygen. Do you have something else than sulfur and oxygen on both the sides? I don't see anything else. I see only these two, right? Then, how many sulfurs? I have SO2 here. It's not sulfur, but it's a compound of sulfur. Fine, that's okay. Even then, you can observe the subscript. I don't have a number, so taking it as 1. So 1 sulfur. And what about the number of oxygen atoms? I see 2 here, so I have 2 oxygen atoms, right? Done? Well, that's great. So now, on the left hand side and on the right hand side, I have sulfur and oxygens. I also have just now made a count of them. How many ever are there? So I see that I am having 1 sulfur and 1 sulfur on both the sides. Do you also see the same thing? In your book, I'm talking about your book. You're writing down everything, right? You have to simultaneously practice along with me. That's when you will learn, yeah? As promised in the last class, I'm going to make you pro in balancing chemical equations, provided you follow all my instructions, yeah? So now, equal number of sulfurs on both the sides. That's great. And then what about oxygen? Even oxygens are equal in number on both the sides. So if you are having an equation in which the number of atoms on both the sides, as in the number of atoms on left hand side and on right hand side are equal, then you call this kind of equation as a balanced equation. What do you call this kind of equation? As balanced equation. So how do you identify if the equation is balanced or not? You have to see if the number of atoms on left hand side is equal to the number of atoms on right hand side or not. If they are equal, then your equation is balanced. If they are not equal, then your equation is unbalanced chemical equation. And there's a technical term for that unbalanced chemical equation, and that technical term is skeletal equation. So just in order to make the things clear, I'm going to write everything that I have discussed in today's class so far. Okay, so very first thing, I'm talking about chemical equations. Okay, and this chemical equation can be of 2 types, of which one is a skeletal chemical equation. What's a skeletal chemical equation? A skeletal chemical equation which does not follow law of conservation of mass, in which left hand side, the number of atoms on left hand side is not equal to number of atoms on right hand side. Are we clear? Are we clear? Right? Now, the other one is balanced chemical equation. What is the other one? Balanced chemical equation. And what is balanced chemical equation? Balanced chemical is an equation in which the number of atoms on left hand side is equal to number of atoms on right hand side. Done? And these balanced chemical equations are the ones which obey law of conservation of mass. Law of conservation of mass. What is meant by obeying law of conservation of mass? LHS equal to RHS. That itself is obeying law of conservation of mass. It in turn means that whatever you were having before the reaction could start, you are having exactly the same thing even after the reaction is start. That's what this LHS RHS concept means. Are we all clear so far? Yeah. So the chemical equations can be classified into 2 types based on if they obey law of conservation of mass or not. One is skeletal, other one is balanced. Skeletal equations are not accepted. You should not write chemical equations even in exams. So what if I have a skeletal equation written on the paper then? What should I do? Simple. You should convert it into a balanced equation. How? You can convert it into balanced equation by balancing. How do you balance this? There are 3 steps. That's what we are learning. The very first step is learning atomicity. You have already learned it. And second step we'll be doing. Before that, let's take a quick pause. Are you all able to follow what's happening? Did you understand whatever we have done so far? Yeah, you did, right? In case you are not understanding, or in case you have any question or any doubt, don't hesitate letting me know in the comment section of the video. Please make sure your concepts are clear, especially the concepts of chapter number 1 from your syllabus, which is very, very important. Okay, so now I'm taking you back to step 2. What is step 2? Step 2 is equalizing the number of atoms on both the sides. What is this? All of a sudden something new, right? No, not something new. In case you are having a skeletal equation where LHS is not equal to RHS, then you should apply step 2 to equalize left hand side atoms and right hand side atoms. But then how can you equalize left hand side atoms and right hand side? What is going on? Let's take one more example to understand that better. Okay, write down this example now. Say you are having, let's take a simple example to begin with. Okay, so say you are having an equation. Like what? Like I am having an equation CH4 plus O2 leading to formation of CO2 plus H2O. Okay, written down. You write down in the book. Done? That's good. Now I have given you this equation. I'm asking you, identify if this is a balanced equation. If it is not balanced, then balance it. Okay. So let us start the procedure from the beginning. Identify if this is balanced or not. How do you know? Array, first divide the equation into left hand side and right hand side. Divide it. After that, observe how many types of atoms do you have. On one side, I have carbon, hydrogen, oxygen. Carbon, oh, okay. Any order is fine. Carbon, oxygen, and hydrogen. For on the product side, also I am having the same thing. The product side, I'll make my video move like this. Yeah. So carbon, oxygen, hydrogen. I have the same. Now, step one. Step one is to identify how many atoms do you have. How many carbons do you see? I see one carbon on the side of reactants. You should not mix up reactants and product side. Okay, both of them are separate. So count separately. Now, oxygen. How many oxygens do you have here? I get to see 2 oxygens here and I also get to see 4 hydrogens here. Do you also got the same count? Yeah. If you have gotten the same count, you are right. Okay. Follow by. Now in the same way, count the number of atoms that you have on the other side. That's on the right hand side. So you have 1 carbon atom here. So taking 1 oxygens, 2 oxygens here. Hold on. 2 oxygens here. But what about this oxygen? So should I write it separately like I have oxygen 2 times or something like that? In fact, no. On one side, that means on either left hand side or right hand side, if you are having similar atoms in different molecules, it's okay. You can join all of them and write. So you don't need to mention oxygen 2 times. So I have 2 oxygens here plus 1 oxygen here. So totally 3 oxygens. Are you clear with this point? Yeah. So now how many hydrogens are there? 2 hydrogens are there. I hope nobody is having trouble calculating number of atoms. This is the very first step. Okay. So you counted the number of atoms on both left hand side and right hand side. Step 1 is done. So now you have to identify if this is a balanced equation or unbalanced equation. By the way, what is that unbalanced equation called as? There's a name for it, right? What do you call that unbalanced equation as? Skeletal equation, right? That's it. Now coming back. Observe the number of atoms. Now when I observe, I have so-called carbons equal by number, isn't it? On both the sides are carbons equal. I see 1 and 1 carbon, so they are equal of course, right? And then what about oxygens? I see oxygens not being equal. 2 oxygens and 3 oxygens. What about hydrogens? Even hydrogens are not equal, 4 and 2. Only carbons are equal. So can I say this is a balanced equation? Balanced equation has equal number of atoms on both the sides. All the atoms should be equal, not 1 or 2. So this is what now? This is unbalanced equation. This is a skeletal equation. Fine, identified a skeletal equation. So what now? What should we do now? Go to step 2. What is step 2? Step 2 is equalizing number of atoms on both the sides. Because we messed up in that page, I'm writing the equation once more. Okay, CH4 plus O2 leading to formation of CO2 plus H2O. You don't need to write it again if you haven't messed up your page. So carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. So I have 1 carbon and 1 carbon. I have 4 and 2 hydrogen, sorry. And I have 2 and 3 oxygens. Done. Step number 2 is equalizing the number of atoms on both the sides. But how? What's equalizing, by the way? For example, say I'm talking about carbon. It's already equal. There is nothing to do with it right now. So ignore carbon. Okay. I'm talking about hydrogen. I have 4 hydrogens on one side. Then what about other side? I have just 2 hydrogens on other side. So if I want both of them to be equal, what should I do? I should either increase the number of hydrogens on the right hand side, or I should either decrease the number of hydrogens on left hand side. So here comes the set of rules in balancing chemical equation. What are the rules? There are 2 rules, of which the very first one is whenever you are doing step 2. Remember, very strongly remember, you can only use multiplication. Means what? What do you mean by you can use only multiplication? I mean, what's meant by only using multiplication? Why cannot we use anything else? Let's go back to the equation to see this. In order to be able to equalize the number of hydrogens on left and right hand side, I can choose to multiply either the left hand side atoms or the right hand side atoms with some number. Still didn't get it right? Hold on. Now I have 4 hydrogens on one side, 2 hydrogens on other side. I can use multiplication anywhere of my choice, either left hand side or right hand side, to bring the number equal on both the sides. So now, if in case say I'm multiplying the number of hydrogens on the left hand side with some number, maybe with 2, what happens? The number still increases. Will it be equal? Is there even a chance to equalize? I don't see a chance to equalize at all. No, not at all. So it cannot be that. Then what it has to be? I'm just trying to erase the scribblings that I have made. So you have 4 hydrogens. You can use multiplication and now try it on the right hand side. Why trying it on right hand side? Array, whenever you're using multiplication, it always increases the value after multiplying, right? So I'm using it on a lesser value so that after multiplying the value increases. So now I have 2 hydrogens on the right hand side. I want to multiply this number with some such value so that the final answer becomes 4. But why the final answer should become 4? Because I want both the sides to have equal number. Because I have 4 on left hand side, I am dying to make the same number 4 on the right hand side as well, but one condition is I should use only multiplication. You're getting my point, right? Okay, fine. So only using multiplication we are doing it. So which number can be placed over here? Can you try some numbers? Maybe 1. 2 into 1 will be 2 itself. No use. Then maybe 2. 2 into 2 is 4. So the number that I am trying to multiply here should be 2. Don't worry if you are having a blur idea, not so clear or whatever, because we are going to do the same with oxygens also. Okay. Now, before we could do the same with oxygens, let me summarize once more. Whatever we have done so far, I'm summarizing. We have taken a chemical equation, and after taking this chemical equation, we have counted the number of atoms on left hand side and right hand side. And after counting the number of atoms on left hand side and on right hand side, before we could apply this to oxygen, I have one important thing to share with you. So now you have made modifications to number of hydrogen atoms, right? So you should be applying the same modifications in the equation as well. What does that mean? It means the number that you have used to multiply over here, you should be using the same number. You should incorporate the same number even in the chemical equation. How do you do that? It's very simple. What are you multiplying with? You are multiplying hydrogens with 2, right? On which side are you doing this? You are doing this on the right hand side, correct? So now on the right hand side of the equation, wherever you are having hydrogen, just before that hydrogen you have to place this 2. Why before that hydrogen? This is the second rule. What is the first rule? First rule is using only multiplication. This is the second rule. What is the second rule? The second rule is using the number that you have multiplied in order to equalize the number of atoms should be placed in the chemical equation. And where it should be placed in the chemical equation? Whichever atom you have multiplied, very before. And in place of prefix, you have to be placing that number. And if I do so, what will be the resultant equation? If I do so, the resultant equation will look like this. You will have CH4 plus O2 leading to formation of CO2 plus H2O. But what have you done to H2O over here? You have multiplied this with 2. And why have you multiplied this H2O with 2? Because in order to equalize the number of atoms, when you have taken the total count of atoms, you were having 4 here, you were having 2 here. In order to equalize both the sides, you have multiplied this with 2. You have multiplied the number of hydrogens with 2. You used the same number in place of prefix. Did you understand? But now, something important that you need to notice is, whenever you are making change in prefix, this applies to hydrogen, no doubt, but this also applies to oxygen, right? The very first step that we have learned, calculating number of atoms, says the same thing. Now, keeping that in notice, let us make modifications to number of oxygen atoms present here. Initially, we are having 2 oxygens and we were having 3 oxygens. This is what we have had at the beginning, right? This is the beginning. Now, in this case, after making modifications, what is the fresh count of oxygen? Can you please count the number of oxygens on the right hand side? You have 2 oxygens plus 2 oxygens. So it's no more 3. Then it is what? It is 4. Did you understand this point? Is this clear to you? Yeah? We'll be practicing so many equations so that you get that confidence. But anyways, understand the steps that you are taking up. Okay? So now freshly, you have 2 oxygens on the left hand side and 4 oxygens on the right hand side. Correct? So 2 and 4 is the count. Even now they are not equal. So you have to equalize them. How? You have to equalize them only using multiplication, because that's the rule of balancing. Now, on which side should I use multiplication? That's common sense that we use multiplication to increase the value. So you have to use it on the side whichever is having less number of atoms. So you should multiply 2 with some such number so that your answer becomes 4. Why answer should become 4? Because you have 4 as the maximum number on the opposite side. And your intention is to equalize both the sides. So your answer got to be 4. So now you suggest a number using which the answer could be 4. Of course, it has to be 2. So again, the number to multiply with is 2. Fine. This means if I can multiply the number of oxygens on the left hand side with 2, the equation becomes equal or balanced. Okay, but then how do I incorporate the same thing into the chemical reaction? I can do the same in the chemical reaction by multiplying or by placing by placing number 2 just before oxygen, like this. Yeah. So now after doing so, I have 2 into 2, 4 oxygen atoms on the right hand side and also on the left hand side. So now all together, let us place this equation. Let me write this equation in the fresh page to help you understand better. And this time I am giving you instructions. You do it freshly once more, right? So now the equation is CH4 plus O2 leading to formation of CO2 and H2O. Step 1. Step 1 is finding atomicity or finding the number of atoms present on both the sides. Okay. So carbon, hydrogen, oxygen. 1 carbon and here is 1 carbon. Hydrogen, 4 hydrogen, here is 2 hydrogen. Oxygen, 2 oxygen, here is 3 oxygen. This is the first step. Done. Any questions or any doubts? No confusions, is it? Now, step 2. Step 2 is equalizing the number of atoms using multiplication. Okay, so carbons are already equal, so forget about carbons, it's relaxed. Now, next one is hydrogen. So now you have 4 hydrogens on the left hand side and you have 2 hydrogens on the right hand side. And as a result of this, the equation is not balanced, it is skeletal. Now, in order to balance it using multiplication, you should multiply the right hand side hydrogens with some number so that it becomes equal to 4. What can that number be? If you know tables, you can answer this. Number has to be 2. So now that means on right hand side, if you multiply the number of hydrogens with 2, the equation will be balanced to some extent. Now, in order to incorporate the same thing into the chemical equation, you have to place this number 2 before hydrogen on the right hand side. So where is hydrogen on the right hand side? It's here. So place hydrogen here. But because you are placing hydrogen here just before, placing number 2 before hydrogen, this applies to oxygen count also, according to step 1 that we have learnt in the first video. And as a result of this, the fresh count of oxygens become 4. Here are 2 oxygens and here are 2 oxygens, right? So now, even if it is 4, it's not equal. So now on the lesser side, I have to multiply with some number so that the answer becomes 4. And that some number again can be 2. Course, logical. Now you have to use this number 2 on the right hand side of the equation before oxygens in order to equalize the number. So here is oxygen, I'm using 2. So now placing this particular equation along with the changes in the fresh page, CH4 plus 2O2 leading to formation of CO2 plus 2H2O. This is what we have made changes with, right? So now you check, does it have equal carbon atoms? Yes. Does it have equal hydrogens? 4. 2 into 2, 4. Yes. Does it have equal oxygens? 2 into 2, 4. And 2 plus 2, 4. Yes, finally all are equal, which means this is the balanced chemical equation. Finally, right? But then you must have found this procedure to be too long because you're doing it for the first time. But honestly speaking, this is the simplest method. I'll summarize it. Balancing chemical equations has 3 steps. Step 1, atomic, or you have to find number of atoms. Step 2, equalize number of atoms on both the sides using only multiplication. Step 3, make changes with the numbers that you have multiplied in the equation. But when you're making change, remember you have to change only prefix. You can't change anything else. That is also the rule of balancing. Okay. So now this is how we balance chemical equations. Today we have learned how to balance chemical equation. Video number 3 or the next video will be balancing actually challenging equations. Okay. So I hope the video has been of some help to you. But let me tell you, if you're just listening, you will not understand anything. You have to take the pen and you have to write each and everything that you are understanding or that I am asking you to write. The instructions need to be written down. Only then you will be able to do it. Watch this video once more and be ready for our third video, wherein we are going to practice some 3-4 equations in the same video in order to get that confidence, right? So in case you want to learn something else, in case you want to suggest some equations to balance, you can let me know through the comment section. I'm always open to the comments. Okay, so great then. I'll see you all in the next video. Until then, bye everyone.